Hey guys, so today we're going to be doing some virtual doodle notes. So in the past, I have done these as printed versions where you could color and fill in the information as we went along with them together in class. But this year, since you guys are not with me, we're going to try doing them digitally. So what I'm going to do is I'm going to try to record me doing them. I'm going to try to edit out hopefully a little bit of wasted time, but I want to get these things to you so that you have them in your notebook. So we're going to be talking about seasons and day and night. You guys submitted slides to me last week where you explained how you thought day and night happened and how you thought the seasons occurred. And for the most part, day and night, people had that down. So day and night has to do with the earth. It's got two sides, the spinning around. There's going to be light shining on one side all the time. But what side that is changes as the earth spins. If you happen to be on the side getting the sunlight, day. Side not getting the sunlight, night. So if you'll notice over here on the side of your slide, I have a clear, transparent yellow rectangle. We're going to line that up here on our earth as close as we can to right there where the equator meets the axis of the earth. So that yellow box represents sunlight. We're going to come in here with a text box. So you're going to be adding a lot of text boxes here. So I'm going to type sunlight. And I'm going to make it a little bigger. Give me just a second. All right, so this box is the light from the sun. So we're kind of imagining there's sun somewhere here in the middle shining out onto the earth. And so this area that's inside the yellow square is getting light from the sun. Anything that's not in that yellow square is not getting that light, so it's going to be night. So on your area over here, I've got two gray half circles that we can come in here and put on the other side of the earth. And that's going to show us that this side of the earth is dark compared to the other side that's light. And that's going to be our day and night. So I am going to come in here, make a text box again. I'm going to type day. And I'm going to leave a little space and type night. And then give me a second, I'll format those. All right, so I made them a little bit bigger, a little more colorful. And I'm going to rotate these onto their side like this by grabbing that little rotation stick. And then I'm going to move these over onto my picture over here, just so we know. Day is what's on the yellow side and night is what's on the gray side. So half of the earth is always in shadow, half of the earth is in light, and that's how we get day and night. Now, the next question that I asked on that sheet was, do you have an idea how we get the seasons? And so some students had a pretty good idea, but there was a common misconception that came up quite often. And that was that the earth has an elliptical orbit, which is true, and that at some times of the year, the earth is closer to the sun, which is also true. However, that is not the reason that the earth is warmer sometimes, because did you know the earth is closest to the sun in January? So does that explain why January is cold? I don't think so. So I want you to look up here at the top of your slide. It says a common misconception is that the seasons on earth are caused by its distance from the sun. But earth is actually closest to the sun in January. So we're going to click in here and type January. And so if it is closest to the sun in January, and at our house at least, it's cold in January, that can't be what causes the seasons. So we have to have another explanation. And so the explanation is that Earth's axis is tilted out of its orbital plane. So I have this word tilted is super important, so I made a little highlight box for that. And so it's actually tilted 23.4 degrees out of the orbital plane. So we are going to add a text box. We're going to type 23.4, and I'm going to make that really big. So give me just a minute. So it is 23.4 degrees from the orbital plane. What does that word orbital plane means? If you're not sure, we talked about the word orbit when we were doing our vocabulary last week, and we said it was the path that the Earth travels around the sun. So the Earth's orbit would be that path that travels around the sun. So imagine that the Earth, that path that it travels, if you filled all that in and filled it in like a disk, that disk formed where the orbit of the sun was on the orbit of this Earth was on the outside and the sun was in the center. That would be the Earth's orbital plane. Now, in a perfect world, if the orbital plane is flat, the Earth would be perfectly straight up and down next to that orbital plane. We would expect the Earth to be spinning exactly at a right angle with the orbital plane. But it's not. The Earth is actually tilted 23 degrees off of vertical. So that's the angle we're talking about. So to illustrate this in your notes, come up here and grab the line drawing tool and draw a straight line, as straight up and down as you can. And I'm going to increase the line weight here a little bit so we can see it. And then I'm going to move this line over here, and I'm going to make it intersect here where the equator and the tilted axis meet, hopefully right there on that line. I'm a little too far. Let me get it perfect. All right, it's not perfect, but it's close. So that angle formed by those two lines, that's that 23.4 degree angle that results in the Earth having seasons. So let's draw a line to remind us about that. I'm going to choose a curved connector. I'm going to attach it to that purple dot right there, and I'm going to draw a lovely arrow that points at that angle so I won't forget. Again, I'm going to make my line a little thicker, and then do you see these little segments up here? If I click this one, it allows me to make an arrow on the end. So I just connected with an arrow my 23 degrees to this angle right here. So the Earth is tilted out of its orbital plane 23 degrees, and that tilt is what makes the Earth have seasons. Now I'm going to come in here really quickly and label. This part is clearly not to scale, but this is where it's showing the Earth is closest to the sun. We said that happens in January. So on the far side, when it's furthest from the sun, that's going to be July. So I'm going to label those. All right, so I labeled January, closest to the sun, July, farthest from the sun. The other thing I want to add as a little note here, the orbit is not a circle. That's true. It is elliptical. It's a little flattened oval here. So I want us to put that vocabulary on here as well. Add a text box. Right here, I'm going to add a little text that says Earth's orbit is not a circle. It's an ellipse. That was one of the vocabulary words that we had last week. So remember, it is an ellipse here. And hey, for good measure, do you know what direction the Earth orbits? Counterclockwise. So let's add that as well. So counterclockwise orbit. Now, sometimes it's hard to remember what direction counterclockwise is. So I want us to add some arrows. So if you come up here to this icon to add a shape, the second option for a shape to add is an arrow. So if we put an arrow in here, then we can rotate it to go the right direction and show the path that this is taking. So I'm going to make this kind of orangey. I like that. It stands out. So we'll copy these, put them all around to show that it's moving in a counterclockwise orbit. So I got 2 arrows there, and through movie magic, I'm going to make it 4. All right, now we got 4. It'll take you a little bit longer. You can pause. I just don't want the video to get crazy. So Earth is orbiting around the sun, counterclockwise orbit. And you're going to see that we have this angle that's going to affect the way the sun is hitting the Earth. I have made 2 additional videos that go with this. If you'll pause right now and go watch those other 2 videos about how the light hits the Earth, that's totally fine. Or you can help me add the rest of the stuff to your slides here and then watch those other 2 videos. But we got to watch all those videos to get all the information. So The video I'm going to talk to you about is one of the things is a lamp. I've got a video about a lamp. So these two flashlights, same flashlight, same energy is coming out of both flashlights, but they're angled differently. So I'm going to type here, same amount of energy. So the same amount of energy is coming out of these two flashlights, but it's coming out at a different angle. When you watch the video, you'll see the explanation for why. But when you're putting energy into a small area, you're going to have more energy. It's going to be warmer. If you've got it angled, it's going to be a larger area and you're going to have less energy per square inch and it's going to be cooler. The video explains why. So we're going to label this up here, smaller area, warmer. Over here, we're going to label it larger area, cooler. All right, I typed those in. So I also made warmer red because that's a nice visual to help you remember, and larger area, cooler, blue. Now, let's take that information and apply it to our situation down here where we have that sunlight shining from the earth. Now, I told you that in the video, actually, I'm not sure I did. All the light that leaves the sun and hits the earth is traveling in a straight line. The reason for that is the earth and the sun are so far apart that if you had light angled up even a little bit, by the time it reached earth, it would go way over the top of earth. And if you had light angled down just a little bit, by the time it reached earth, it'd be way below the earth. So only the light that is shining directly straight at earth is going to hit earth. So because of that, you can imagine all of the light that is shining from the sun to the earth is hitting the earth in a straight line. Absolutely straight line rays. Oops, that is not a straight line. I'll do better. Much better. So I'm going to imagine there's kind of sunlight shining both ways. This is a two-sided diagram. We know that there's not two earths on either side of the sun. But if you imagine that the light is always shining in straight line at the sun, then you're going to get direct rays hitting either right here or right here. So on this side, when the axis is tilted away, all your direct line light is hitting below the equator. So direct line light is a smaller area. It's going to be warmer. So below the equator, we are going to have summer. So I am going to color that portion of the globe red for summer. If the bottom of the earth is summer, then the north must be winter. So we're going to add that on the top there. So this indicates winter. When the North Pole is pointed away, it's going to be winter. On the other side, here we've got the North Pole pointed towards the sun. Direct rays are hitting above the equator. So above the equator, it is going to be summer. Same thing, opposite pole pointed away. So in the southern hemisphere, it is going to be winter. And once we have these in place, I'm going to label them summer and winter. So I've labeled 3 of these. Oops, I did a bad thing there. Undo. Redo. All right, so I have winter here, summer here. The opposite's going to be the case here, summer here. So that means we're going to have winter over here. Indirect rays, cooler, winter. Direct rays, warmer, summer. So when I ask you what causes the seasons, there are 2 things. 2. So we're going to type those right up here under the seasons, okay? So text box. First thing, the Earth's tilted axis. So that tilted axis is responsible for the seasons, but the axis alone wouldn't do it. The other thing that happens is that they have Earth orbits the sun. So the tilt causes there to be a different amount of energy in the northern hemisphere and the southern hemisphere. But if the Earth was sitting still, it would always be hotter on one side than the other. We would cook. Because we're also orbiting, those seasons change. So the Earth's axis causes there to be a difference in temperature. The orbit causes those seasons to change throughout the year in a cycle. So we've got notes on how the seasons form. I hope that makes sense. We will be testing whether or not you understand that. I say testing. I will be asking you some questions tomorrow to see how well you understand how this works, but hopefully that made sense. Please, please, please also watch the videos where I explain how the light angle affects how much heat different locations get.